So in last video, this is what we have seen as a definition of the conditional independence. You can see the same expression through the conditional probability, making use of the conditional probability and the multiplication rule. So this is what? This is nothing but the conditional probability. So we can make use of the conditional probability and we can write like this. So this is nothing but equal to the probability of A intersection B intersection C divided by the conditioning event, that is the probability of C, right? And we can make of use the multiplication rule and we can expand this probability, that what is the probability of happening of this event A and B and C, right? तो हमारे पास क्या है कि लास्ट वीडियो में मैंने क्या बोला था कि इवेंट सी अकर हो चुका है, राइट? दिस इज गिवन. सो लेट्स कंसीडर दिस इवेंट सी एज अ फर्स्ट इवेंट. सो इट विल अकर विद सम प्रोबेबिलिटी. अब अगर इवेंट सी हो गया है, अंडर दिस कंडीशन आई वांट टू हैव द प्रोबेबिलिटी ऑफ दिस इवेंट बी. अब क्या हो गया है कि सी और बी अकर हो गया है. सो सी और बी अकर हो गया है. सो बी एंड सी हैज़ बीन अकर्ड. अंडर दिस कंडीशन आई वांट टू हैव द प्रोबेबिलिटी ऑफ दिस इवेंट ए. So this is what the normal multiplication rule, right? And divided by the total conditioning probability. So this will get cancel. अब देखो कि हमारा assumption क्या है? Conditional independence, right? मतलब कि given this condition C, our belief about happening of this event A and this event B should not get changed. राइट अगर मेरे पास कोई भी, जैसे कि यहाँ ये तो देखो, चलो ठीक है, दैट विल बी इक्वल टू द प्रोबेबिलिटी ऑफ बी गिवन सी, राइट? एंड लुक एट दिस हियर, we have given this condition C and we have also given this additional condition B. And if we are saying that this is conditional independence, then this additional condition should not affect the happening of this event A. So we can assumption, with this additional assumption that we have this conditional independence, we can write this probability of this A under this additional condition that is given B, that should be equal to the same as जो हमारा पहले इनिशियल बिलीफ था, पहले इनिशियल कंडीशनल बिलीफ जो था, that will be same as the probability of this event A given C, right? So this is, we are writing under the conditional independence. Also last time we talked that this ordinary independence doesn't imply the conditional independence. हम ऐसा नहीं बोल सकते हैं कि अगर A और B इंडिपेंडेंट होगा तो अंडर दिस कंडीशन C और अंडर दिस इवेंट C A और B जो होगा वो इंडिपेंडेंट होगा, ऐसा हम नहीं बोल सकते. so this is what this is statement mean, that the ordinary independence or just the independence doesn't imply the conditional independence. और एक चीज़ देखो आप कि कंडीशनिंग करने के बाद जो है इंडिपेंडेंस पे अफेक्ट पड़ता है. जैसे कि इस एग्जांपल में जो मैंने लिया था, ए और बी बिफोर दिस कंडीशन इंडिपेंडेंट थे. जैसे ही मैंने अंडर दिस कंडीशन ए और बी को कंसीडर किया, वो डिपेंडेंट हो गए. सो कंडीशनिंग में अफेक्ट इंडिपेंडेंस. Let's look at an example. So you have two unfair coins and we have given some conditional probability that under given this information that you have this coin A. So this is your evidence, this is your given information और this is your given condition कि आपके पास coin A है. Under this information that if you toss the coin you will get the head with the probability 0.9, and you will, under this condition that you have coin A, you will get the tail with the probability 0.1. now you again toss this coin A. So again you are getting the head with the same probability 0.9. that means the first toss is independent of the second toss. So happening of this head is not changing your belief about happening of this head in the second toss. That means ki under the given condition, or under the given condition that you have this coin A, the toss of coin are independent, right? So again you have this probability 0.9 of getting the head in the second toss, and again you will have the getting the tail with the probability 0.1, right? And similarly for this situation also, so in the first toss maybe you will have the tail, and again in the second toss you will get the head with the probability 0.9, and you will get the tail with the probability 0.1, right? So this is one world where you are residing, right? One world, I mean to say, under the given condition that you have this coin A. So this is known to you that you have this coin A and you are doing the tosses, and these tosses are independent. So one toss has nothing to do with the second toss. Similarly, again you have another world where you have this coin B and you are tossing this coin B, and you will get the head under given information that you have this coin B, that you will get head is the probability with 0.1, and you will get the tail with the probability 0.9. And again the second toss is independent of what you are getting at the first toss. So you will get the head with the 0.1 and you will get the tail with the probability 0.9. Similarly for this, the case of when you have got the first on the first toss you have got the tail, and on the second toss you are getting the head with the probability 0.1 and getting the tail with the probability 0.9. So this is the first condition, that you have this coin A and you have these conditional probabilities, right? And this is the second world where you have this coin, given this information you have this coin B and you have these conditional probabilities, right? And let's suppose that you are choosing these coin A and coin B and they are equally probable. That means you can choose this coin A with the probability 0.5 and you can choose this coin B with the probability of 0.5. Now my question is that, are coin tosses independent? अब आपको एक ये कन्फ्यूजन आ रहा होगा कि यहाँ पे मैंने क्या बोल रहा था कि कॉइन टॉसेस जो है इंडिपेंडेंट है, तो ये आपको गौर करना होगा कि ये मैं कब बोल रहा हूँ। ये मैं तब बोल रहा हूँ जब आपके पास कोई एक कॉइन है, मतलब कि गिवन अ कॉइन टॉसेस आर इंडिपेंडेंट। सो लेट मी मेंशन दैट वन ऑल्सो। सो ओवरऑल मैं क्या बोल रहा हूँ कि अंडर द कंडीशन द प्रोबेबिलिटीज आर इंडिपेंडेंट। सो ओवरऑल मैं बोल रहा हूँ कि कंडीशनल probabilities are independent. So you have given this coin, right? And you have given this coin A, right? So you have given this evidence A, and happening of this head is 0.9. So this probability I am referring to right now, right? Again you have this given this coin A, and you have got the head on the first coin. Then what's the probability that you will get head on the second coin? So that is same as earlier. So आपका initial belief जो था under the condition, that is same. That means कि ये कॉइन टॉस और ये कॉइन टॉस जो है वो कंडीशनली इंडिपेंडेंट है. तो यहाँ पे जो मैंने एक्सप्लेन किया था ये चीज़ को, राइट. सो ये आपको पता चल गया ना कि व्हाट इज इंडिपेंडेंट एंड व्हाट क्वेश्चन वी आर आस्किंग आर कॉइन टॉसेस इंडिपेंडेंट फॉर द होल मॉडल, राइट. एंड these probabilities are conditional probabilities. This one is also conditional probabilities, but these probabilities are conditionally independent because given this coin, right, the tosses are independent. So let me mention that one also. Given a coin, the tosses are independent. Right. Now what we are asking, that are coin tosses independent for the complete model. So are coin tosses independent? So we are referring to the complete model, the whole model. In general model, are the coin tosses independent? That is what we are asking. So how we can do that? We can find this by comparing the unconditional probabilities and the conditional probabilities. So let me first of all find this event, the probability of this event, that probability that we will get the head on 11th toss. Right. So what's the probability of that at the 11th toss we will get head? And right now we do not have any condition or we do not have any evidence, so we can find this probability using the total probability theorem, right. So we have two coins, right, and the we will select coin A or coin B with equally that is equally likely, right, equally probable. So maybe we will select this coin A with the probability 0.5, and since we have selected this coin A with some probability, now under this condition that we have selected this coin A, what will be the probability that the 11th toss will be hit, right. That is the one condition. And maybe we will be selecting this coin B, and given this condition that we have selected this coin B, what will be the probability that we will get hit on the 11th toss. So this is the probability, the total probability of getting hit on the 11th toss. So we can calculate these probabilities because we have given with this probability, so 0.5 into getting the head on 11th toss, given it is coin A, that is with the probability 0.9 plus 0.5 into getting the head at 11th toss, given the this is coin B, is have the probability 0.1, right. So this will be equal to 0.5. Now let's suppose that someone have told you that the first 10 tosses are head. So now you have this evidence that the first 10 tosses are head. Under this evidence, what will be the probability that 11th toss will be head, right. So now we have this given condition, and under this condition we wanted to find that we will have the 11th toss that is head. So क्या ये जो एविडेंस है will affect your belief that what is going to happen on the 11th toss? Would this condition affect our belief that what will happen in the 11th toss. So how we can calculate this probability? We can make use of the conditional probability and we can find this probability. But intuitively, if you look that we have given this evidence that first 10 tosses are head, so that is very much likely that we have this coin A, because अगर फर्स्ट 10 टॉसेस हेड है तो वो कॉइन बी से नहीं हो सकता है, बिकॉज कॉइन बी में हेड आने का चांसेस का प्रोबेबिलिटी 0.1 है. एंड इफ यू सी दैट द if we have this coin A, then we have the probability of head is 0.9. So if we have this evidence that first 10 tosses are head, then it is extremely likely कि हमारे पास जो coin है वो coin A है. That means कि what we are asking is that, so probability that we will have on the 11th toss equals to head given we have this coin A, right? So that is nothing but equal to the 0.9, right? Because if we have this coin A, then getting the head is 0.9. So even we can make of use the conditional probability and we can find this one, so, right? Because what we have done here is that we have gone through our intuition and we have find this probability. But let's look at that how we can find this probability using the conditional probability. So what we are doing, we are tossing the coin for the 11th time, right? So if you look at this condition that the first 10 tosses are head, so you will get the head at first toss, you will get the head at second toss, you will get the head at the 10th toss. Similarly, when you have this coin A, and for this coin B, you will get the head at first toss, you will get the head at second toss, and you will get the head at the 10th toss. And 11th toss क्या हो सकता है, वो head भी हो सकता है, right? And again we have the same condition, same that on the first 10th toss we will get the head, और जो 11th toss होगा वो tail भी हो सकता है. Similarly for this coin B also, right? 11th toss जो हो सकता है वो head हो सकता है, और 11th toss जो हो सकता है वो tail भी हो सकता है, right? So these events will favor this condition, right? That first tosses are head, right? So we just need to find so what probability we are finding? We are finding the probability that first 10 tosses are head. So we are finding this conditional probability. So we just need to find probability of this, probability of this, probability of this, and probability of this, and we need to add those probabilities. So if you find this probability, so we have selected this coin A, and we have the total number of how many heads we are getting is 10 heads, right? So that is 0.9 to the power, because each one have the probability 0.9, that is 0.9 to the, and again at the last toss is also even tail, so we can directly take here 11, right? What will the probability of this event? That will be, again we are selecting this coin A, and we have the 10 heads in a sequence and one tail with the 11th toss is tail with the probability 0.1. Similarly for coin B, we have the 10th tosses in a sequence and 11th tosses in a sequence is head, and for this event we are selecting this coin B, and we have 10 tosses that is head in a sequence, and the 11th toss is tail with the probability 0.9. Now if we add all this probability, so this quantity will be very small, this one, right? Because 0.1 to the power 9 will be very small, even this quantity will be very small. So overall we will left with the addition of these probability. So let me go into the next page. Probability that the first 10 tosses are head is equal to 0.5 times the 0.9 to the power 11 plus 0.9 to the power 10, right? And we have to also find the probability that toss 11 is head intersection with the first 10 tosses are head. So probability that the toss 11 is head and first 10 tosses are head, right? So what will be this probability? So देखो फर्स्ट टॉस 11 टॉस जो होना चाहिए हेड होना चाहिए, यानी कि ये और मतलब कि इस इवेंट को कौन सा फेवर करेगा? ओनली दीज टू, दिस वन एंड दिस वन. ये तो बहुत छोटा हो गया तो इसको तो हम ख़त्म ही कर देते हैं, मतलब कि सिर्फ इसको हम लिख देते हैं. दैट मीन्स कि 0.5 इंटू 0.9 to the power 11, right? Now we have to find this probability that the toss 11 is head given that first 10 tosses are head is equal to 0.5 into 0.9 to the power 11 divided by 0.5 into 0.9 to the power 11 plus 0.9 to the power 10, right? So this 0.5 will get cancelled, and if you take the 0.10 common, so we will be left with 0.9. So that will be approximately, because we are neglecting anyhow this these terms in the probability calculation because these are the very small one, right? So this is how you can find this probability, and intuitively we have found this probability also, that is 0.9. So you see that the 10 tosses 10 tosses affects my belief that what is going to happen on the 11th toss. So under this evidence, under this information, the occurrence of this probability that we will get the head on the 11th toss is getting changed or getting revised, right? So overall point is that we do not have the independence between different tosses, right? So before this evidence, what we have found that what will be the probability of this getting head at the 11th toss is 0.5, and now we have this given evidence. Under this evidence we are calculating the same probability but with this revised one, right? So that tells that these coin tosses we do not have the independence between these different tosses. So through this example what we have seen that even we have the conditional independence, right? Because given a coin we have the independent, right? Given a coin we have the independence between different tosses. Given a coin we have the independence between the different tosses. Overall point is that in this model we have the conditional independence, but if you look at the complete model, the whole model, we do not have the independence between different tosses.